Lesson 2-4, Perpendicular Lines, Part 2. So last time we talked about parallel, now let's talk about perpendicular. So I drew for you an example of what perpendicular looks like. So let's talk about what this is. So obviously these lines are crossing each other, so that's one thing, but it's how they cross each other that's important. All right, so to figure that out is we're going to find slope first. So remember, slope is the change in y over the change in x, or the rise over run. So if I go from here to there, or I could have gone from here to here, it doesn't matter where you do the slope, it should be the same wherever you are counting from. So from this point to this point, I go down 2 and to the right 3, down 2 to the right 3. So the slope, your change in y over the change in x for that line is -2 over 3, or just -2/3, keeping the negative sign in the middle. All right, now for the other line, this pinkish, purplish line, we're going to count the slope going from here to there. Okay, so it's going up and over, up and over. Okay, so if I count this, 1, 2, 3, up 3, so it's going positive, and to the right 2, up 3, and it should be 2, but I think I counted the spaces incorrectly. So up 3 over 2, up 3 over 2. So for this line, the slope is not going to be -2/3, it's going to be 3 over 2. And there's no negative sign. So for this one, the change in y and the change in x, or the slope, is 3/2. Okay, so there are two different slopes. Now let's compare them to each other. Let's write them out. So we have -2/3 and we have 3 over 2. So what do we notice about these slopes? Well, they have the same numbers, but not in the same place. It's flipped. So 2 over 3 becomes 3 over 2. So we call this a reciprocal. Okay? So what you see is the same numbers, but flipped. But we also see this. One of them is negative, and the other one is positive. Okay? So this is what we call opposite reciprocals. Sorry, it took me a while to think of the word right there. Opposite reciprocals. So basically, no matter what numbers you have, right, you're going to have a number on top and another number on the bottom. But when they're perpendicular, they flip, and one of them will be negative and the other one will be positive. So you'll see this kind of relationship, opposite reciprocals, whenever you see perpendicular. Okay, so that's how you prove it. Now in this picture, there's one more thing I should point out. When these lines cross, they cross at an angle on all four corners. Basically, all four corners, if you measure them, have the same angles. 90 degrees, 90 degrees, 90 degrees, 90 degrees. So that makes right angles. So it's almost like a perfect X. Like if you just focus on the line, they cross and they make like the perfect X, or the perfect T, if I fix this around. Okay? But the way you know that it's actually perpendicular is by the slopes. Since right now you can't measure the angles, you're going to measure the slopes. All right? So that's perpendicular lines, guys. Let's do one example. So write an equation of a line that passes through 4, 5 and is perpendicular to y equals 2x minus 3. Okay, so the slope here, the m is 2. but let's write it as a fraction. 2 over 1. This is our slope. But remember, they want a new line. They want a new line that will be the opposite reciprocal of this slope. So what does that look like? We flip it, and we make it negative. And now you're looking for a line that'll be the opposite reciprocal of 2, which would be negative 1/2. Okay, so this will be the new line that is perpendicular, but you need to find the y-intercept. You need to find b. How do you find b? With your x and y. We're going to take these numbers and we're going to plug them in. So I'm going to take the 5 over here, and the 4 is taking the place of x. Okay. We have negative 1/2, and that's going to be multiplying. Okay, so the x and the 1/2 are multiplying, so I have negative 1/2 times 4. Turn that into a fraction. Negative 1 times 4 is negative 4. 2 times 1 is 2. I only put the negative on top, so the 2 is a positive down there. You simplify that, you get negative 2. So your problem now looks like this. Okay, we're solving for b. Remember, we're missing that. We need the b. So I'm going to move minus 2 with inverse operations. I'm going to do plus 2 to both sides. The 2 cancels out. So now I'm adding 2, right? The 2's are gone here. They're gone. B equals 7. Okay, so what is my new line going to be? What is this line? Y equals negative 1/2 x plus 7. And here's my answer. So these are two lines. This was the original line right here. And the line that is perpendicular that goes through this point is this line. I'm going to sketch it real quick just so you can kind of get an idea of what it would look like. So just imagine for a second. 1, 2, 3, up 2 over 1. The first line looks like that. That would be your first line. The new line would be at 7. So let's just 1, 2, 3, 4, 5, 6, 7. Down here, it's going to go down 1 over 2. It's going to go like that. Something like that. And yeah, if we were to look at this carefully, like draw the entire lines crossing, you would get that 90-degree angle where they cross perfectly right there. All right, so yeah, that's what it would look like. Example number 2. Okay, are these lines parallel, perpendicular, or neither? How do you tell? With the slopes. So we have to identify the slopes of both lines. Right here, luckily, this one is written in slope-intercept form, so we have our slope already here. The b really doesn't matter. We don't really care about the b. We're just looking at the slope of 1/2. Okay? So, if they're parallel, here's what I'm looking for. If they're parallel, the slope of this line will be exactly the same. It'll be 1/2. If they're perpendicular, it'll be the opposite reciprocal. It'll be a negative 2. Or negative 2 over 1. Either way. Okay? And if it's neither, it's something completely different. It's something else. It's not these two. If you get another slope, another number over another number, then it's neither. Okay? So, to figure it out, we need to identify the slope here. But this is written in standard form. So you guys remember standard form? You have your AX plus your BY equals C. It's written in standard form. To compare them, I need to turn this into this. I need to go from standard to slope-intercept. So we're going to solve for y. I'm going to start by moving the 2x. I'm going to move 2x to both sides. Okay. Now I get this. Now I could do 6 minus 2x, but I don't write down 4 because they're not like terms. But I'm going to write it like this, because I want this to look like mx plus b. I'm almost there. There's a negative sign. Now, whenever there's a negative sign, treat this like a -1. Treat it like a -1. You have to get rid of that -1. How do you get rid of it? We're going to divide everything by -1. Okay? So, the -1s would cancel out. You're left with y. -2 divided by -1, that's +2. And 4 divided by -1 would be -4. Okay, so here's my new line. Here's this equation. This equation. Oh, I'm sorry. I totally messed up. That should have been a 6. Where did I get 4 from? I got to correct that later. I apologize. But again, remember I said the b really doesn't matter? It doesn't matter what this number was, because what I care about is this one, my 2. And guys, my slope is 2. Okay, so let's compare that. Is my slope 1/2? Is it identical? No, so they're not parallel. Is my slope a negative reciprocal? Is it -2/1? No, it's +2. So it's not this and it's not this. So what does that mean? Your answer is neither. It's a completely different number. It's a different number. You could put it over 1 if you want, but it doesn't matter. It's not parallel and it's not perpendicular. It's something else. So it's neither. All right. One more question and then we're done. And this one is a word problem. So let me have it up on the screen. Okay. So here we have a landscaper plans to install 2 new plants or 2 new paths in a park. The new fountain path will be perpendicular to the east path that leads to the fountain. And the new picnic path will be parallel to the fountain path that passes through the picnic area. What are the equations in point slope form for the representations of the new paths? Okay, so this is kind of easier. We're not using slope intercept. We're using point slope. So it's this equation. So that's the good news. Okay. Now we need the slope and we need a point for 2 new paths. So the fountain path and it says picnic path. So I'm going to label this. We're going to do a fountain. We have the fountain path. And I just misspelled fountain. The fountain path and the picnic path. Now, before I worry about my answers, let's talk about the path that already exists. So when I look at that path, I'm going to write an equation for it. And again, the easiest one to write is this one. So I notice that it starts at 2. Now the slope, you have to be very careful. Now when you look at the slope, it goes up 1, 2, 3, 4, 5. So it goes up 1/5. So the slope is 1/5x. Okay, so this is the path that exists right there. This is the red path. Okay, this is the red path that's drawn right there. All right, we're going to make 2 new paths. Now the fountain path is going to be perpendicular. So this one is going to be perpendicular. Okay, and the picnic path will be parallel to this one. Okay, so let's start with this one first. Before we get to the picnic path, let's do this one. So we want to go to the fountain. I need the points. That point is 15,2. So the point I'm using is 15,2 to the fountain. All right, now here's the good news. If I'm going to use this equation, I know I'm going to use those numbers. So I'm going to start with y minus 2 equals, I don't know the slope yet, x minus 15. Okay, remember, x1 and y1. x1 goes here, y1 goes here. Now for the slope. If it's perpendicular to this, then what we're going to see is the opposite reciprocal. So the reciprocal would be 5/1, and instead of the opposite would be negative instead of positive. So that means my slope is -5. There we go. And guys, that's it. That's the equation in point slope form for the fountain path. Now, let's read the picnic path. The picnic path is going to be parallel to this one. Okay, so this one is going to be parallel to this one. Now, if they're parallel, instead of doing the opposite, it's going to be exactly the same slope. So guys, if they're parallel, the slope is going to be -5/1. The point for the picnic area, which would be 5, 6. And there's my information. There's my slope, there's my point. My answer would look like this. Y minus 6 equals -5, x minus 5. And those are my two equations in point slope 4. Here's the picnic path, and here's the fountain path. And that's it.